Mitch has spoken at previous Supply Chain Insights conferences, and Mitch is a serial entrepreneur. And I met Mitch about 10 years ago, and he was working on really a outsourced machinery company into China. And he's been an early pioneer in 3D printing, additive manufacturing, and so he's going to talk about where is the current state of 3D printing. And I saw some printers the other day at Jabil. We've come an awful long way. So Here you go, Mitch.
Thank you very much. Yeah, I've had the opportunity to visit Jabil Blue Sky as well. What an impressive operation. So they're doing a lot of very creative things. As Laura said, I started my career just to set the base as a machinist. I didn't go to college. I went through an apprenticeship program. Tool and die maker, aerospace machining. Ended up in the airline business doing rapid manufacturing of aircraft parts. And then I ran engineering and technical operations for Northwest Airlines. Then I started a 3D CAD software company. I sold that one. Then I started a company called MFG.com, online marketplace for manufacturing globally, and then sold part of that to Jeff Bezos, and then Fidelity and private equity. That was in 2013. And then I thought, what do I want to focus on now? And it was tempting to go do another software as a service or marketplace type business. But I felt like making things is a really interesting opportunity right now, especially if you were to start from scratch and do it in a very digitally connected way, natively. And so I started two different companies, and I'll touch on the reasons why they're different companies in a moment. But one is doing just CNC machining with low volume, very fast lead times, very fast quotes, just fast execution. And the other one, Fast Radius, is focused on additive manufacturing. And that's what we're going to touch on primarily now, is sort of the state of additive manufacturing, 3D printing. Where is it today? Where's the hype? Where are we in the hype cycle? And so we'll run through that. So we're at a really interesting point. And by the way, I use the word 3D printing and additive manufacturing sort of interchangeably. In the industry, we think about additive manufacturing. Why? Because we're adding material to build a part, to grow a part of something. In machining and traditional, we're using subtractive manufacturing. We're taking a block and we're subtracting away from it. Now, 3D printing is not new. It started in the 80s, and it's been a long, slow evolution of progression with a number of different technologies and use cases. And it really began with just doing prototypes that weren't so dimensionally accurate. They weren't very structurally integral. But it was awesome. For the first time, you could actually hold a physical part in your hand without having to tool up for it. So lots of different technologies emerged through the years. Fused deposition modeling is one. That's this one, where there is filament, almost like a wire of plastic coming through a spool, through a nozzle, and it extrudes it into a 2D pattern, and it builds layer upon layer, building up a part. Now, this technology is very mature, and it makes very dimensionally accurate, strong parts, but they're not cosmetically beautiful. And we can do parts that are very tiny with this technology, all the way up to parts that are 1 meter square. Interesting example. There's two use cases I'll talk about. One is for a large computer manufacturer that's making some specialty servers and server racks. And we print brackets for them, custom brackets. They don't care that it has a shiny surface finish or it has a certain Pantone color. It just needs to be, it's a strong bracket. On the opposite end of the spectrum, we just printed a lot of large parts for a company that builds special aircraft for military operations. And they were building an airplane, they need to do it really fast. And things like gearboxes, APUs that would go in there were long lead time. But they wanted to keep building the airplane. So we printed replicas of all the avionics boxes, gearboxes, the APU, and they used those to put in place to drill the mounting holes, run the wires, run the tubing, run everything. And then 6, 8, 10, 12 weeks, when that actually comes in, they take out the 3D printed one and plug in the real one, and all the plumbing and wiring is already done. Interesting use cases. So FDM is a key component. And then one of the newer technologies that we're using today is from a company called Carbon. And this is digital light synthesis. It's pretty incredible. So what's happening in that one is you put a liquid resin into a tub, small tub, piece of glass, and through the bottom of the glass is a projector that takes the part, the 3D CAD model, and slices it in tiny slices. And then every time that projector pulses through the glass, it hits that resin and it solidifies that layer. And so it's just like constantly rising. It looks like Star Wars. It looks like you're just pulling a part out of a pool of liquid. Very interesting. The surface quality is incredible. It looks like an injection molded part. And the properties, now, after this, it does go into an oven through a baking cycle for a couple hours. But at that point, you get properties that are akin to injection molded parts. So we're really competing with low volume injection molding here. And this is some of the materials that we can do on that machine. Not just rigid plastics or things that are like Ultem, that are high temperature plastics, but we can also do rubber, silicone, flexible parts, print special seals. So this is all building up to where this is going to be a really interesting supply chain story. Now, so things that are happening, other use cases. So this machine that I just showed you and that flexible material, this is where Adidas is using that to print that sole on the shoe. They're able to print it as a lattice structure, right? Because you're able to, one of the benefits of additive manufacturing is that you can print things that you cannot make any other way because of the geometric complexity. The way that shoe sole is made, you couldn't print it, but it's engineered in such a way with this lattice structure that it's an incredibly comfortable, shock-absorbing shoe. That technology is also being applied into other places and other things that have impact that I think you're going to begin to see in the pretty near future, and things that just could never have been traditionally injection molded. So there's really 3 segments where additive manufacturing is taking off. And it's on-demand supply chain, on-demand products, on-demand manufacturing. So we'll talk first about sort of the on-demand product. So you may have noticed on our slide that UPS is part of this 3D printing business. UPS is our partner in the business. They own part of the business. And you might think, why? Well, one of the theses when I first started Fast Radius was I wanted to be near a major logistics hub. I wanted to do so that I could make parts until the last minute and still get it on an airplane somewhere for next morning delivery. So I talked to the 2 major logistic providers here in the US, and UPS, and I was really trying to figure out where to locate. UPS, I figured it would be Louisville. So I started talking to folks, and then very soon I was invited to a meeting with the very, very top people at UPS and learned that additive manufacturing and digital supply chain is very high on their strategic radar as a company. A couple of the comments I heard from their executives were, back when fax came along and people stopped shipping around documents for signature, it impacted their business, right? There's something happening here that is analogous, but it's in physical parts this time. And UPS, being thought leaders, said, we see this coming, and we can be the bug or the windshield, and we choose to be the windshield. So they're taking a lot of our technology and solutions out to the UPS customer base through the UPS supply chain solutions and evangelizing. And what we're discovering is really interesting opportunities where people that want to move to a digital virtual inventory. So it's an on-demand inventory for spare parts, repair parts, tools that you don't know where you may need it and when you're going to need it. There's companies that have SLA agreements where they have to provide spare parts within 48 hours or whatever time frame that is, or 24 hours. And in some cases, that part may never be ordered by the customer, but it's part of an SLA. So they're getting customers to revise and relook at SLA agreement. What if I could make that part within 24 hours and I don't actually have to inventory all that? So really interesting supply chain impacts from this use case. Then we're working on things like custom earbuds. Things where we have developed an app where you can take a picture or a consumer can take a picture of their ear. We capture data. We automatically drive that to create earbuds that fit each person's ear individually for the workout segment where you don't want it to come out when you're doing aerobics or yoga or dancing or whatever it is. This is one example, but of many. A lot of wearable products are being customized. And producing these high-quality parts, it's advanced manufacturing. It's digital. This is what the factory looks like with the ones that have the carbon, these machines. The company is called Carbon. The parts are not carbon fiber. So it's a little bit of a misnomer there. I want to clarify that. But what we're looking at, it's a clean environment, and these things are running, and it's pretty high speed compared to what you've ever seen with printing before. It's injection mold quality, and the amount of parts that these can produce in a day is pretty mind-blowing, especially when you look at the quality. It really does rival low-volume injection molding. Now, where we're seeing the use cases today is low-volume, high-value products. Medical device companies, we're doing cases for companies that make specialized small equipment where they may make 500 or 1,000 units a year. People that have high-value, low-volume products where there's a high risk of change, design iteration, you don't want to commit to a tool. That's the type of people we're seeing here. We're seeing people doing interesting geometry challenges like microfluidic chips, where you can take a part and you can print channels through it. And you can only drill a straight hole, right? But when you print it, you can print all sorts of channels that curve and intersect and combine liquids and things, very big in the medical industry. These are the types of customers we're running production for. Now, as we talk about on-demand manufacturing, digital virtual inventory, where it becomes really interesting with UPS, obviously they're a global company. Major hubs around the world. And then they've got, I think it's about 900, if I'm not wrong, forward or field stocking locations around the world where they strategically hold inventory for customers. Now think about the day when we have this high-end additive manufacturing equipment in these 900 locations around the world, and we've assembled a global manufacturing cloud that can react very quickly to digital virtual on-demand inventory requirements. We think that's pretty special. It doesn't happen overnight. This is going to take a while to build out. At this moment, we're in Louisville, Kentucky, and we're in Singapore. Europe coming soon, and we'll just continue to build that out. We don't want to get too far ahead of the technology because new technology is coming very, very fast in this segment, particularly with metals and metals printing. Plastic is getting really good. Metals is about to be really good. A few things that we're playing with now that we have access to that are on the horizon. There's some game changers in metals happening. So we think it's a lot of fun to help companies bring products to life, things to market that just weren't possible before. We have companies, when we show them the capabilities or when they get exposed to the capabilities, they become really excited. They start bringing products back off that they had designed, but they just couldn't bring it to market profitably because it was low volume, or there was some complexity to it. And we've got several companies now that are bringing products back that they had designed a few years ago, and then they shelved them because the cost to introduce the product was too high. But today it makes sense. So, oh, that was not mine. Okay, good. We'll take someone else's thunder. That was a lot quickly. Thank you.
Okay,
you.
Mitch, so I want to ask you a question.
Sure.
So where do you think we are in the maturity of additive manufacturing? You know, have we progressed a long way, and where will we be in 2030, right? What's practical?
Yeah, I think we're still embryonic, honestly. I think we're still embryonic. And I think it's taken us 20, almost 30 years to still be in the embryonic stage. But I think the next 5 years is a rocket ship. And it is the time that companies need to get smart, that applications need to be developed, engineering teams need to begin thinking differently. And I think it's just like the bonsai tree? This is what we're upon, and it's about to really just grow fast.
So when you think about the atoms in the supply chain, that acceleration, where do you see the biggest value? Is it in service parts? Is it in contract manufacturing? Where do you see it?
Yeah, so it's on contract manufacturing at the beginning, but I don't think additive's ever going to compete with, Jabil's high volume customers that are, just too many parts. That injection molding makes sense. But at the beginning of a product cycle, there is a lot of iteration that happens. And companies go slower sometimes in introducing products because they don't want to make a wrong move and go build tooling too fast. Tooling is expensive, it's a big commitment. But if you could get the product in the market faster and then continue to iterate even after you've launched it, before you lock in tooling, it's really going to accelerate the product development lifecycle, which is already fast.
So there are a number of plastics manufacturers, material manufacturers in the room. How do they help that acceleration, right, in terms of bringing products to market for additive manufacturing?
Well, if you're thinking about materials are the key to additive manufacturing, really. But there's a lot. Material science is really the big frontier right now. As companies are designing materials that react to the light synthesis or to whatever things and develop more and more mechanical properties. Aviation, we have to pass the burn test. And so the plastic companies that make plastics and resins, I think they're going to be really big winners for this, as long as they're staying, up with the curve in engineering new materials.
Okay.
Good.
Well, he's going to come back and be on our digital manufacturing panel here in a little bit. Thank you, Mitch.
Good. Thanks for the opportunity.
Thank you.